Today's video is about significant figures. Significant figures are ways for us to represent the accuracy of a number, or maybe to give us an understanding of how accurate a number actually is. What a lot of times will happen is we'll do calculations and we'll get numbers of decimals in the 7 or 8 or 9 decimal place range, and we'll think those are all accurate numbers, and it turns out they're really not. And what significant figures and the rules for doing calculations with significant figures will do for us is kind of help us better represent the accuracy of the number of the calculation that we're doing. What we need to do first is start off with zeros. Zeros can be the most confusing thing with significant figures, quite honestly, because sometimes they are significant and sometimes they're not. So what we need to do is define two different types of zeros for us. One of them is what we call a leading zero. That's something like 0.001. This has two decimals that are the leaders, or zeros that are the leaders in this number. They're ahead of the 1. So they are what we call leading zeros. And then they're what we would call trailing zeros. And you can probably guess that would be the opposite. So it might be like this, 1,000. This has 3 trailing zeros. It could be something like 0.100. This has 2 trailing zeros. So if they happen before a number that's significant or a non-zero number, they're called leading zeros. If they happen after, they are what we call trailing zeros. Now, leading zeros are not significant. So what I'm going to do is run through some examples here on the side and talk through some of these. And with the understanding that some of you have seen some of this stuff before, you've done some stuff with your physical science or maybe even chemistry, so you have a little bit of a background with what significant figures are. If not, this video should get you up to speed and should give you some pretty good idea of what's going on. If not, make sure you come and talk to myself so we can get you on the same page as the rest of the class. So starting with this number right here, we have 2 leading zeros. They are not significant. So this right here would just simply have one significant figure, and it's the 5. This number here has 2 significant figures, and that is the 5 and the 7. This 0, this trailing 0, is not significant. However, this number right here has 3 significant figures. Now, you might be wondering, what's the difference? I have 570 and 570 in a little decimal place. The decimal place makes all the difference. Once that's there, that indicates that whoever made this number, put this number out there for a calculation, made sure it was measured to 570. It's not, this one could be like 571, 572, 570.5. We're not exactly sure. This decimal indicates that now this is exactly 570 something. There might be a decimal place that got rounded, but we don't have to worry about that. We just want to worry right now about these first 3 numbers which are considered significant. The 10 is also considered significant for a similar reason. The 3 numbers here are all considered significant for a similar reason. Once you have a decimal, these trailing zeros become significant. Again, here we have 2 zeros that are leading and 2 that are trailing. There are 4 significant figures in this calculation, but these are the 4 that are significant. The last 4 digits, including these 2 zeros, are significant again because of this decimal. And then this last one has 3 trailing zeros, but only the 3 and the 7 are considered significant. So there's 2 significant in that. So just kind of running through these examples, you might know what's going on, you might not be exactly sure why these are considered significant. So what we're going to do is show you some simple rules and basically come back to some more examples after that. So again, rules for determining significant figures. The first one's the easy one. Non-zero numbers are always significant. So a number like 34 would have 2 significant digits in it. That's not that big of a deal. 2 and 3 are the ones that get a little more complicated. If we understand leading zeros and understand what that means, they are always not significant. So, if I just give you a little simple example, something like 0.007 has 2 leading zeros ahead of it, not considered significant. I could do, if I had a number like 10, I could put literally an infinite number of leading zeros out in front, never getting any more significant. Trailing zeros, again, it's a little bit more difficult. If I have 1.0, that would be 2 significant figures. If I just have 1, probably not a good example. Let me just shift gears a little bit. If I have 0.001, that has two leading zeros that are not significant. When I put these here, I'm now indicating those are significant. If I have something like this, 100, that should have been 100, that is two trailing zeros, but there's no decimal. So those would not be considered significant. So let's try a couple more examples on our next page and kind of walk through those rules. This might be a good point to pause the video to take some time to write these rules down so you can use those as a reference on our next page. So back to our examples. Right here, 525, all non-zeros, three significant figures. Very simple. Number 1000, we just talked about this on the last slide that was up. 100, this is the only number of significance. There's no decimal, so one significant figure. Two leading zeros in 0.0032 are not significant, so this has simply just two significant figures in it. 705.001, that has 6 significant digits. Anytime you have zeros in between non-zeros, automatically make those significant. 10.0, saw this on the very first slide, that has 3 significant figures. Again, that decimal makes this, that someone measured this to be exactly 10 of something. It might be 10 feet, 10 people in a group, 10 meters, 10 milliliters. This one right here, again, once the decimal's there, these zeros, even though this is two trailing zeros, they become significant. This zero in between the 5s is automatically significant, so this would have 5 significant figures. And this last one, trailing zeros but no decimal. Once the decimal's gone, there are no significance to these zeros, so it says 2 significant figures. That ends the video that identifies the numbers with significant figures. Our next video will take into account the operations when you're working through multiplication and division, how to treat their significance.